Welcome back. Now we have Sasa Popovic with us. Sasha has been working within Microsoft Serbia for more than 10 years now, and he is currently allocated in the Development Center Serbia as a project manager. Hi, Sasha. Welcome.
Hello, Milos. Good to be here.
Yeah, great to have you here. How are you?
I'm good.
Yeah. Okay. Sasha, first of all, thank you and the Microsoft Development Center Serbia for supporting the Azure Saturday Belgrade conference. We wouldn't be here without you, and of course the audience and all the groups around the Azure back in Serbia. So
you're welcome. You're welcome. It's always good to support these kind of events. So we love to support and to participate.
Nice. So you will be talking a little bit more about Azure SQL Managed Instance today.
Right.
And some new features, options within.
Yes. So today we will talk about Managed SQL, Azure SQL Managed Instance, and how it can be used for building distributed database applications. So that is the topic.
Okay, great. In that case, I have shared your presentation, and the floor is yours.
Okay, great. Thanks. Again, welcome everyone to the session on building distributed database applications. Once again, thanks to all the sponsors of this conference. My name is Sasa Popovic. I have been with the Microsoft SQL team in Belgrade for 10 years, most of the time as software engineer. But since last summer, I've started as program manager in Managed Instance team. So let's quickly take a look at the agenda for today. So at the beginning, for those who are not familiar with Azure SQL, I will give a short introduction, and I will talk about a few different products that we have in Azure SQL. Then we will talk a bit about why distributed database applications, why do we want to do something like that, what's the motivation, and what are the options. Then we will take a look at the architecture of our demo application that we will be building today, and we will see the demo, we will see this in action. So Azure SQL is a cloud database product based on SQL Server, and it has a small family of services. The first one I would like to mention is Azure SQL Managed Instance. It is platform as a service. It is essentially a managed SQL server that offers the broadest SQL Server engine compatibility. It is fully managed, meaning that you don't care about the operating system, you don't care about the server. Those are managed for you, high availability, automatic backups, that is all coming with the product behind the scenes. It is evergreen. The bits are upgraded regularly every few months. And this is the product that one would like to use if wants to migrate existing application or to modernize it in the cloud or build new applications in the cloud. Next in the line is Azure SQL Database. This is also platform as a service. This is a relational database service. So the main difference between these two is Managed Instance is the entire server. Azure SQL Database is just a managed database. And finally, there is infrastructure as a service product. It's a SQL Server on Azure virtual machine that is most convenient if you want to lift and shift your system to the cloud, but you still want to have full control over the operating system and the server itself. So having that in mind, today we will be using Managed Instance to build our distributed database application. And let's see why would we want to do that. So data redundancy is one of the frequent requirements. So sometimes we need to have the same copy of data in multiple places, because one server probably does your OLTP workload, and then on another copy you want to run some analytics, reporting, some additional querying. So then there is a need for disaster recovery and high availability. You might want to have multiple copies of the data in order to be able to recover effectively from disastrous events such as network outage or power outage. And if you have data on multiple places, application can quickly fail over from one place to another, and with that achieve high availability, so that application and users don't notice the downtime. Then some applications are very sensitive to latency, so data locality is important. For these applications, they cannot afford to run queries on servers that are on different parts of the continent or different parts of the globe. So for these kind of applications, we are distributing data on servers that are geo-distributed, so that they are collocated with the applications that will consume the data. Partitioning is a general technique that helps when you need to overcome the limitations of single server, whether it's limitation in storage, in performance, or anything else. So in order to achieve good performance scalability for large volumes of data, we want to go with the partitioning. And finally, whatever we are doing, strategy is important. It is good before building the solution to know where the data is generated, who can access it and modify it, and where and how the data is consumed. Because if we go with everything everywhere approach, it is usually not a good idea, because those kinds of systems are typically difficult to maintain and they're not performant. So I'll talk a bit more about partitioning. There are generally two types. One is vertical, where different tables or even different columns can be split to different servers. Let's say we have a set of tables and columns that are being frequently changed, and they have relatively small volume of data. So we would keep this data on one server with certain characteristics, and then data that is slowly changing, maybe has a larger volume, we can put it on a different kind of server, and we split to optimize for the hosting data. Then another type of partitioning would be horizontal. Here, typically, all the servers that are taking part in this partitioning have the same schema, meaning the same tables, but the different rows are hosted on different servers and databases. So in order to build a distributed database today, let's see what technologies will we use for this. So we will be using Azure SQL Managed Instance to host databases. We will be using Elastic Database Library to set up and maintain shards for our sharding. So databases on managed instances will be shards, and one of the databases on these managed instances will be the shard map database. It is the database that will keep the metadata on the sharding, on the partitioning. In addition to this, we will be using linked servers. This will allow us to query with T-SQL all the data, regardless of whether it is sitting on the local server or on remote servers. And in addition to all of this, we will be using distributed transactions. Distributed transactions will allow us to query or modify the data in a transactionally consistent fashion. So with all these things in place, we will have a system that has all the characteristics of a database, and the data will be distributed on multiple instances. So let's take a look at the architecture of the application that we will be creating. So it's a simple application that tracks data on products, customers, and their orders. We will split this data into master data, that is products. It is the data that has lower volume. It does not change so often. So we will, for optimal performance, we will keep a copy of this data on every shard in every location. Then customers and their orders will be local data. So only customers that are active in certain region, they will be their data will be hosted in that region, and applications, local applications that work with this, they access only this data for optimal performance. On the other hand, this local client application, we have set of admin applications. These applications have few things to do. So the first thing is these applications will be maintaining the shard map for the entire system. They will also be maintaining the master data. So if we need to change anything in the products, one of the admin applications will be doing this. Because data is geo-distributed, application is geo-distributed, managed instances are typically in different locations sitting on different virtual networks. So in order to have all this working, we will need to set up virtual network peering between instances. And in order for distributed transactions to work, we need to set up SQL, we need to set up server trust group and have instances within it. Server trust group is a concept, and when created, when instances are assigned to it, what it does under the hood, it exchanges certificates between instances, and with that, it establishes certificate-based trust between instances, which is needed for the distributed transactions to work. Okay, so one more thing to mention. There is typically, these days, there is confusion between distributed transactions for managed instance and MSDTC. MSDTC is distributed transaction coordinator that has been traditionally used with SQL Server on Windows for a long time now. So MSDTC is today not yet supported for managed instance. But what we have done instead of that is we have enabled managed instance to act as a distributed transaction coordinator. So even though we don't have MSDTC in this entire setup, if the application is using a .NET programming layer or T-SQL programming layer, distributed transactions will transparently work. And one of the instances that participates in this, in the distributed transaction, will act as a transaction coordinator. Okay, so let's go over to demo. So what we have here is a set of managed instances. We have managed instance X1 and X2. They are in West Europe, and they are on virtual network VNet X1. We have another managed instance called Y10. This one is in North Europe, and it is on virtual network VNet Y10. So different regions, different virtual networks, and as we mentioned, to make all this work, we will need to set up VNet peering between these two virtual networks. What is important for VNet peering is that virtual networks need to have distinct address spaces. So this one is 10.5, this one is 10.6. So they satisfy this prerequisite. So VNet peering can be set up between them. Currently, there is no peering, and I will start the workflow for creating. This workflow is creating the vice versa peering from the Y to X. So we will provide the name for this as well, and choose the virtual network that we want to peer to. It is the Y10. So process, and in a minute it will be done. So another thing that we need to set up are linked servers. So here I have virtual machine that is sitting on a VNet X1, and here we are connected to X1 SQL MI, and now we see that the only server that we have currently here is the local server, so there are no linked servers. So we will add link server Y10, and we will add the login for this server. And then we will do the same for X2. And we can see now that remote server, linked server Y10 is added, and X2 is added as well. Of course, we can query the local server. Because we have linked server, we can query X2 linked server. And if the VNet peering is in place, and it is set up, we can also query the Y10, and we get data from there. So at this point, we can query the data. We can also change the data, but if we try to run distributed transaction, it will not work. So I will start it, but it will run until it times out. So the setup is still simply not ready for this. So let me cancel this query. And let's go back to the managed instances. So another thing that we need SQL Trust groups prepared. SQL Trust groups, as well as the distributed transactions, are in public preview. So one inconvenience with SQL Trust groups is that currently you can only put 2 instances. So if you need to set up server trust group between multiple instances, you need to create STG for each pair. So few of these STGs have already been created, but I will now create STG for X1, X2. Okay. We will leave this running. And the final thing that we need to do for distributed transactions to work, we need to open the required ports. So in network security groups for 2 virtual networks that we have here today, network security groups, it's a concept that acts as a firewall. It is just a simplified version. What is important for us here today is we need to allow 1433 port. We need to allow this range of ports. And these ports are usually, when you create a virtual network for managed instance, these are by default allowed for virtual network traffic. But one specific port for distributed transactions is 5024. This port is not allowed anywhere at the moment. So to allow this port, I will run Azure PowerShell. So let's quickly take a look at this script. What it does, it defines the port that we want to allow. We get the NSG for the Y10, and we allow and outbound traffic for the 5024. And then we do the same for the NSG for X1. So let me run this. I haven't been active for some time, so I need to authenticate again. Okay. So this will be running for a moment. While this is happening, we can go back to server trust groups, and we can see that server trust group between X1 and X2 is created, and its status is enabled. So this prerequisite is met, and with the script finishing, We can now refresh the network security groups, and we will see that the port we need for distributed transactions is now allowed for both NSGs, both VNets, both inbound and outbound. So let's now go back to the distributed transaction that previously did not work. So what we are doing here today, let's give it some distinct value and execute this. So what this will do, it will insert the data into local server, local database, and then it will perform 2 inserts in the 2 linked servers. So let's run it. It's done. And if we take a look at the latest data in this table, we see that the new values are inserted. Okay. So we have set up our managed instances. They are now ready for linked servers. They're ready to run distributed transactions. So we can now deploy our demo database. So currently, the only database that we have on these servers is this dummy database DB01 that we have used to test distributed transactions. And what we will do now, we will create a database that will host our shard map metadata. And we will create 3 databases that will host our shards on the 3 managed servers. So let me run this. So what we are going to do next is we'll run the script that will create tables for products, customers, and orders, and this will run for all 3 managed instances. So note that here I'm not using same as here. I'm not using any linked server or anything like that. So I'm using SSMS SQL CMD mode. So I'm specifying here where I want to connect. So this is all the actions that are happening on different servers. It actually happens through different connections. Okay. So this should be done in a second. Okay, while this is happening, let's give it a few more moments. While this is happening, and before we create the schema in the tables, okay, it is done. So we can create the schema. Okay, it is done. So let's refresh the view. So on the X server, we see shard database and the database that will actually host the metadata. And here we have the 2 shards. Now, currently, the shard map catalog is empty. So if we run this, we have no data here yet. And to set up the shard map, we will start shard map manager application. And actually, before we do that, let's take a look at the code snippet that explains what will be happening behind the scenes. So when we run this application, it will create the shard map manager, and it will create the shard map. So we can have several shard maps hosted in this database. So we give a shard map a name so that we can identify it, and then we have a series of steps where we create a shard for a shard map, and shard is defined with the server and the database that will host it. So for us, this will be server X1 and database alpha. And then we assign certain tenants or points to this shard. So here we're using a list shard map, meaning that for sharding, we will provide a list of tenants or points that will be assigned to this shard. So we have assigned here 2. Then we are creating the next shard on a new server, new database. We are assigning some tenants, points, and so forth. So let's do this. Okay, the application is done, and it has displayed the shard mapping that we have created. So we have shard is called shard map demo. We have one shard on server and database, and we have these 4 points mapped in the range of hundreds. We have the second server and the third server, and we can see the same thing from the metadata in the shard map catalog database. We see shard map. We see 3 shards, and each of these shards has 4 assigned points. So once all of this is in place, everything is ready for our client applications to run. So we will start 2 client applications. So that we can see the data in 2 different regions. Let me just align this so that we can put everything on the screen. We can also start the admin application. Okay, so let's connect this one to the Y server. Okay, so the data that we have, so the schema and the data that we created with the script, we can see it now in the client app. We see the master data on products. It is identical in both regions, and we see data on customers that is specific for each region. So X1 has customers in the range of hundreds, and Y10 has customers in the range of 200s. Here in the admin app, we see basically the same metadata. We see that on this server, these are the mappings, then mappings for 200 in Y10, and mappings for ranges of 300, it's in X2. So let's now take a look at the part of application that would want to update master data in a single transaction. So we want to update all of these in single transaction. What we will be using for this is actually we'll be using SSMS and store procedure called create new product. So let's see what this store procedure does. Here's the T-SQL. So here is the T-SQL code for this store procedure. So what it does is it will receive the information on the ID and the name of the product. It will begin distributed transaction, and it will insert this data into the local server and then into remote servers. And finally, it will commit the transaction. So if we move this a bit to the side, and we call this procedure to create a new product with ID 7706. Currently, it is not in our application. We run this, and data is inserted within a single transaction in all our charts. So the next thing that we want to do is a bit more complicated scenario. Admin application will now do the following. So imagine we want to actually migrate a customer from one server to another server. What we would need to do for this is we would need to alter the shard map mapping. So we want to remap this customer from its current location to the new location. But that's the change in the metadata. And then we also need to move the actual customer data from customers table, and we want to also move the related orders. So let's again take a look at the code example for this thing. So what we are doing in .NET here, we want to move the tenant. We provide the tenant ID customer. This is the customer ID from the source server and source database to destination. We are starting the new transaction from .NET with the new transaction scope. And then everything that happens here is a single transaction. We are marking current mapping as offline. This will effectively disable client applications to modify any data for this tenant because shard map will not provide active connections to this tenant. So we mark it as offline. We call the method that actually moves the customer data from the source to destination. On the destination, we yet don't have the tenant mapping, so local application of the destination still cannot change this data because shard map cannot provide connection. And finally, we are deleting the mapping on the source, and we are creating the mapping for the target server. In the end, we complete the transaction, and with this, the migration is complete. So let me check the settings here. So we are moving from X1 to Y10. We are moving tenant 102. It is this one. So I will start the process. And we see that within single transaction, this mapping has been changed. customer is moved and its related order has also been moved to the destination. So final scenario that I want to show is the following one. So let's say that by an error in the system, we have assigned this order to the wrong customer. So we have assigned it to the customer 103, and it should actually go to customer 203. So it was some kind of typo. So to do this, what we will do is we will again in some admin application that is in charge for fixing this, we will start the transaction scope. We will use shard map and open connection for the current customer, and we will delete the order from that shard. We will open a connection for the correct customer on the proper destination. Shard map will give us that connection. We will insert the data into that one, and we will mark the transaction as completed. So let's see that in action. So we want to move order 8802 from customer 103 to customer 203 that is in this shard. So I will invoke this code, and the data will be moved. So note that for this example, we actually did not make any changes to the shard map. We only used the shard map to get the proper connections, and with that to make the changes with the data. Okay, so that was all when it comes to demo. So I hope that I have managed to show how managed instance is a good place where you can effectively build distributed database application where you have all the tools that you would need for one database, so you can query all the data with link service regardless of where this data is hosted, and then you can also query and modify this data in a transactionally consistent fashion with distributed transactions. I have provided resources for the topics that we talked about in the PowerPoint. So I guess that afterwards I will find a way to share this PowerPoint with the audience somehow through the conference portal. That was all from my side for today. Thank you.
And great presentation. Thank you, Sasha.
You're welcome.
So yeah, definitely what we've been seeing in the past year or so. Before that, the customers were usually using ES to, as you said, lift and shift their databases to Azure. But in the last year or so, they are trying to redesign their applications and to make changes in the databases so they can move more towards the PaaS, which is a great thing, especially when we look at that the PaaS has implemented things like backup or easier setup of disaster recovery things, etc. So definitely great advantages that they can use.
Yeah, and to comment on that, so we also see that customers are keen on using PaaS because it provides all all these useful capabilities, because customers often don't want to manage the infrastructure and everything. They want to improve their business. So from our side, we are also working hard on enabling more and more capabilities for managed instance, so that migration from on-premise or from infrastructure as a service is as smooth as possible. So when you're building PaaS, it's not an easy thing to do, because there is always a balance between what can be allowed, and there is also time is needed to make all these on-premise capabilities managed and available in the cloud. But we are getting there. So distributed transactions is something that managed instance was missing for a while, and as I mentioned last October, it became available in the public preview, and we are going towards global availability.
GA soon. And great. Tell me, is data migration assistant also a tool developed by your team?
Data migration is not developed by our team. So I didn't have much experience with it, but I know that it is used a lot for migrations to the cloud. I think it is used for migrations to all of different services in Azure SQL.
Yes, very, very useful. We used it numerous times. It helps you when you decide to move your on-prem SQL Server to the cloud. It deep dive into it, analyzes everything, even your queries, so it can tell you what you need to fix in order to use certain service in Azure. Okay. And one more question regarding the MI. What I've noticed, and to be honest, I deployed the last one almost a year ago. It took a couple of hours to deploy SQL MI. Is that still the case?
Yes. So we had some improvements during the last year when it comes to managed instance provisioning time. So it's probably faster than it was a year ago when you created one. But we are still not where we would like to be. So we are improving that part. Currently, if you're creating the first managed instance in your virtual cluster, in your virtual network, it takes a bit more time. I'm not quite sure, but I think it's around 1 hour. And then later instances, or maybe that is 2 hours, and then additional instances that you are creating in the existing virtual cluster, they are created faster. But as I said, we are aware that this low provisioning time is not something that is it's not good for a cloud service. So we are working hard on improving that.
Yes, yes. A lot of teams are working with the infrastructure as a code, so deploying that through Azure DevOps, it does take some time, but great to hear that you're working on improvements. Once again, thank you very much for a great presentation. I don't see any more questions in the chat, so I would say that would be it for today.
Okay, thanks a lot. Bye-bye.
Thanks for coming. Bye, Sasha.